My name is Ryan Mermall. I work for Cimco Americas, based out of here in Chicagoland. But obviously, we primarily work through our reseller channel, obviously MLC CAD Systems being one of those. So I want to thank them for the opportunity to go ahead and show you guys all the Cimco Probing add-on for Mastercam that Cimco obviously has developed, and kind of explore more into that product. To start, what I wanted to show though is maybe some additions to Cimco. You may have seen our name floating around, somewhere before. Primarily, if you're using Mastercam, you're probably going to see us with the editor options. So when you go ahead and post out your G-code programs coming out of Mastercam, we do have a Cimco version that's included with that. Cimco obviously has a number of different products as well. That's not our only thing. We also do offer some machine simulation, along with also the DNC communications to transfer files to and from your CNC machine. So Mastercam is obviously going to get you, there with the G code, but getting it from the computer to the machine. If you don't want to use USB sticks and this and that, we can certainly assist with networking those machines as well. Of course, with that, we do also offer a database that can go with it, and that allows users to put in user permissions and different capabilities of tracking revisions. Some of that may be required based on ISO certs or things of that nature. Along with then data collection for your machines, seeing machine utilization, uptime, downtime reasons, and that way you can make educated decisions based on the data that's actually running on your machines. And then, of course, to round everything out, of course, is going to be the Cimco Probing, and that's going to be an add-on for Mastercam. So that's going to allow you to utilize your machine tool probes in order to create cycles, in order to go ahead and set up work datums, in-process inspections, aligning the part, to the machine, things of that nature. So to jump in, the first thing I wanted to go over here is basically some supported controls that we offer with Cimco Probing. Now, with this, we have either supported controls, and that's going to be controls on the CNCs that will offer for any type of probe manufacturer. It could be Renishaw, Bloom, Marposs, things of that nature. What those are going to include are, say, like Heidenhain, your Akuma, your Siemens, Makino, right? So this is going to be for those kind of controls, right? They're going to support then really any probe brand, based on that, because it's using its own cycles across the board. As far as probe cycles themselves, if we look at the specifics of, say, Bloom or Renishaw, then you're going to see some different options there, such as your Brother, your Fanuc, your Haas, Mazak, Akumas, things of that nature. So again, it is going to be primarily from mill. It is a question that comes up quite often as far as, hey, are lathes supported? And with that, they are to a point. As of right now, currently, they're going to be supported on the machines that utilize the same milling macros for that, such as like a Mazak Intergrex or some of the Akuma, or I'm sorry, the Siemens or Heidenhain side of things as well. So if you have questions, obviously regarding that, feel free to reach out to myself or the guys here. We certainly, take a look at, what you have and see if that would be a good fit or not. Primarily what I'm going to be going over today is just on a Haas machine. I'm on a UMC 750, so utilizing, some of the options there for us. To get started, let me go ahead and open up my Mastercam part file here. And I first want to start off with just giving you a brief overview of what we're going to be doing, on maybe a part like this, and then we can always go back through and actually recreate some of those cycles accordingly. So the first thing I'm going to do is go ahead and just step through, some of these process here as far as simple probing, on my part. So the first thing that I'm going to do, and again, I'm going to be located in, say, like a UMC 750, so it's going to be on a 5-axis machine. With that, what that allows me to do is I can first go ahead and update my Z-axis orientation, and that's going to make sure that the stock is in fact square to the machine. With that, then I'm going to go ahead and level out my B-axis and align that one to my machine, again, making sure that everything is sit flat. And then, of course, we're going to set up our G54, or it could be 55, 56, so on and so forth, offsets in both X and Y, and then also in Z. So as you can see in Mastercam, I do have my my origin here to the center of the part. There's where my F9 auto cursor is. And with that, I'm just going to go ahead and backplot some of my operations here from the start. So we can see that with the Cimco Probing, it's going to get loaded up into Mastercam. It's going to be considered a C-hook add-on. And with that, we can go ahead and put the probing routines really anywhere, you know, in there on a current toolbar, a new toolbar, right mouse button click menu, and I'll show that here in just a second. Each of the probing operations are going to be considered a operation in my operations manager there. And that's going to allow me to then, as any normal toolpath, go back in, change parameters, and this and that and the other. So again, with that being a standard operation, we can go ahead and backplot those as needed. So the first thing we're doing on this part is I'm going to be coming down, and I'm actually going to be taking 2 hits on the back of the part, and this is going to then update the C-axis. So once the probe cycle touches the left and the right side of the part, it's going to go ahead and compare that, make sure it's then straight, and then it's going to apply some comp to then my G54 C-axis, variable there. From there, it's also going to go in, and then we can go ahead and do our B-axis, right? So make sure that's sitting flat, followed by then going in and doing what we call like an outside rectangle feature. That's going to go ahead and touch on all 4 sides of the part, naturally making the center of the part my 0 location. And then lastly, I'm going to be coming in down in Z, touching off the top of the stock, and then calling that my new Z0. So a couple options that we took to get there, and we can kind of flip, you know, back and forth, between there before jumping into, you know, some of the inspection routines here, is I'm just going to slide over to my one part that is going to be that same exact part, just without the probing operations already in there. So to create some of those from scratch, again, what I have here is a Cimco tab up along the very top menu bar of Mastercam. And then, of course, I have my Cimco probing routines based in there. But you're not also limited to that. You could also put them into a right mouse button click menu or elsewhere, you know, inside of Mastercam if you wish. So to start off, the first thing I'm going to do is go to my Cimco Cycle Probing. It's going to allow me to pick on one of 3 categories. We have the workpiece alignment, which is going to be aligning the C-axis B or an A-axis. Workpiece datum, which is going to be setting a work offset for me to touch off. And then, of course, we have workpiece inspection, which is going to be all those same cycles, just doing in-process inspection. And we can tell it remachining this or that, you know, from there, outputting to variables, you know, things of that nature. So to start off, I'm going to go to the workpiece alignment and do my C-axis, which is going to be in the X and Y measurement there. So what that's going to do is it's going to pop open on top of my toolpath manager, going to allow me to go ahead and select on my probe. If we don't have that already in here, we can simply right-click and then go to the tool manager in order to bring that up. With it, I'll just go ahead and put in a comment to align my C-axis with it. And then, of course, I'm going to go over to my Cycles tab. Now, with my Cycles tab, I will mention I am using some defaults with that. Some defaults that I commonly have set are my measuring height, my safety distance. That's more like a standoff distance. We have a clearance height, maybe an over travel. So with that, you can go ahead and customize these cycles or the settings to them, such as a normal contour pocket, you know, things of that nature operation. Allowing you to type in less mouse clicks, things of that nature. Now, what we're going to do here is I'm going to simply right-click in my white area and tell it to go ahead and select on points. Now, the points I'm going to select are just simply going to be the corner points, this one here and this one here. Now, once I go ahead and select on those corner points, you're going to see it's going to open me up and show me the cycle itself, using also the colors, right? So standard Mastercam stuff, our yellow is going to be rapid moves. Any of the blue colors are going to be then more or less your feed moves based on that. Now, I wouldn't necessarily want to touch off just exactly on the corner. Maybe for some reason the stock is going to be, smaller than it is, and maybe then you risk, the probe not touching exactly. What I'm going to do is I'm actually going to shrink that in a little bit in my x-axis, so that way I can touch closer on the part. With that, what I can do here is I can actually take my center mouse wheel if I want, and I can simply bump up my center mouse wheel, and each rotation or each little click of my center mouse wheel is going to move basically like 100 thou there. And that's going to allow me to then simply adjust based on where that probe hit is going to be. And then of course that's in live time showing me where that tool path is actually going to go ahead and do its thing. Now, if you don't want to necessarily use that, you could certainly type in a value. Standard Mastercam stuff, you can right click and use some of your options here. So, in this case, I could use like an X coordinate of a point and go ahead and put that in and select on, somewhere in there. Those are all valid options of how I can go ahead and do that, of course. Again, based on that, you can go ahead and simply roll your mouse wheel if you'd like to go ahead and dial that in. And that's going to be valid for any of these settings really within there. You can see that we're doing it in the Y negative direction, so that's all good to go. And then we're going to be updating our work offset of G54, and this is going to be in my C-axis rotation. So by doing that, it's going to go ahead and create that operation. Because I put it in the very top, it's obviously going to bump everything down accordingly. And then, of course, we can go ahead and backplot and or verify that as needed. The next operation we're going to do moving forward is certainly going to be updating my B-axis, right? So with that, we can go ahead and do that on my my X measurement cycle. And the one thing you're probably going to notice is, again, I am using a Haas post for this, and so with the Haas and the Renishaw, we are going to show you a display of the actual macro. And so that's going to be one thing that's going to set Cimco Probing apart from some of the other options, is that we are in fact referencing the machine macros, the standard machine macros that Renishaw uses, of course. So there's no additional macros needed, to be installed on the control and this and that. It's going to be using the standard ones that were intended and coming with the probe cycles that you probably could program, already. This one, we're going to update my B-axis on. And again, same thing. We'll have our probe here. We'll go to our cycle page. I'll right-click and say select points, and then simply select on the points maybe of the midpoint here and midpoint here. And then, of course, as I did before, we can simply bump those in, a couple hundred thou. Again, still getting an even spread, across my part. But then, of course, with that, we're going to go ahead and update my B-axis in a G54. And again, that's going to allow me to go ahead and flatten that part out. So now that I have my C-axis and my B-axis aligned, and again, this is something that wouldn't necessarily have to be done on, say, like a 3-axis machine if you, actually, indicated your vise in. If you are worried about maybe some, your part maybe not being in square, this or that, you could theoretically use these same cycles in order to do like a G68 plane rotation if your machine would support that. So kind of the same idea. Otherwise, if you didn't need to do that, and again, if you're working on just a 3-axis, this is where you could kind of start in, from the basic. And again, we would do that as a workpiece datum. Now, as far as the workpiece datum, we're going to go ahead and support a number of different options. Again, these are going to be the same options that Renishaw would have here, and again, the same cycles that we're referencing. For instance, on a part like this, because my center of the part is considered my 0 point, I would go ahead and do like a rectangle outside. And that's going to, again, touch base on all 4 sides and then make the center of the part the 0 point. So by going in here, we can again select on our probe. I'll just say G54, center. We'll go to our cycle page, and then I'm going to go ahead and right-click and then select on one of my options. Now, based on the cycle, we're going to give you different options on how we can select on our geometry. As you can see here, of course, we have an option from stock. So that's going to be if we actually are utilizing the stock setup page within Mastercam, we can go ahead and select and read out of that value. We could also select on lines or even a chain. Now, the lines could be wireframe edges or solid edges. Either one would be fine. And then, of course, we have an option for wireframe chaining, with that. I'm going to go ahead and say from stock, again, utilizing what we have there. And again, right away, I get a visual feedback of what's going on. With that, of course, if I didn't want to maybe measure at my default 1/4 inch, again, I could go ahead and bump that down if you'd like, or up as needed. Of course, right-click and use some of your options. You could use like a Z coordinate of a point or, one of those natures. Same thing with safety distance. Like I said, that's going to be more or less our standoff distance. So maybe if the saw guy wasn't paying attention, he cut things a little oversized, we could go ahead and increase that standoff amount. That way we safely position the probe outside of the part, don't risk, coming down on top of the part. Although if we did, we'd catch it with our safety, options there that Renishaw has. But again, you can go in and tell it your safety distance, along with then also a probe over travel distance. So again, if things are going to be a little shorter than what we thought and didn't hit the part at the point that we thought, it's going to go an extra, say, 1/8 inch in order to try to get that and get it to point. Obviously, if it goes past the 1/8 inch and it still doesn't hit it, then it's going to do the standard alarming out and warn you, on that, of course. So again, we can go in, touch off on the center of the part, and then call that now my G54. The last thing I'm going to go ahead and do to set this one up is then I'm going to also tell it my Z-axis and touch that off here. What we can do for that is going to be the workpiece datum. This time, though, we're going to do that as a 0.1 axis. So 0.1 axis allows me to tell it a specific axis that we want to go ahead and probe. And this we can go ahead and say G54, Z-axis, something of that nature. Or cycle page. Right-click, we'll say select points. In this case, we're going to go ahead and select on my origin point. That's going to be my one to hit. And one thing I want to note here is that we do have an option down here called datum set point. What that's going to allow you to do is touch off on the top of the stock, but then say you wanted to account for maybe some material on top of that, and we want to actually drop it down an additional, say, minus 10 thou. That's going to go ahead and allow the probe cycle to then call that at 0, but it's also going to drop an additional 10 thou. That way, when you take, say, your face cut or something of that nature, everything is shifted downwards that appropriate amount. Again, we can compensate for that, of course. So now by putting in all those cycles, I'll run them all through backplot maybe, and that would allow me to kind of take a look and see obviously what's going on. So maybe I'll select on that one all the way up to the alignment. And then of course we can see we're going to touch off the back of the part, rotate that in, touch off on the top of the part, rotate that in, and then of course we're going to go in and hit the sides of the part, and then also our 0 point of the part on Z. So that would be some operations as far as how we can go ahead and set up on my part itself. With that, of course, we could also look at doing it if it was set up a little bit differently. Maybe we didn't have it in a, the center of the part is my 0 point. Maybe we had it on a corner. Obviously a couple options we could do for something like that. I'll just open up a different, part file here. But say we did have a corner set as my 0 position. Again, I still have my stock set up and things of that nature. We would just take a little bit different of approach. Say if I didn't care about the alignments and wanted to jump right into the datums, some options that you could use would then be our corner option, and that's going to do a corner outside. You could also do a 0.1 axis for that. Doing a corner outside, that Renishaw cycle is going to allow you to pick on the corner and then it's going to go ahead and do 2 touches or 2 hits on each side of the part. Now, Cimco Probing, it's going to be intuitive to the fact that if you notice, I have some settings defaulted here, and right now my corner is set to lower left. That's just going to be what it defaults to. However, if I go ahead and right click and select on my lines, say that my lines are going to be this guy and this guy, you're going to see it's actually going to update automatically to be then my upper left instead of what it had as default. Again, right away we can see now what the cycle is doing, make any changes as needed. We can certainly update a different work offset to that, as needed too. And then of course we can say okay to go ahead and create that cycle. Now for people that maybe don't want to touch on it, and take 2 hits, maybe they wouldn't necessarily want to use the corner outside, and that's where then you could go ahead and use maybe like a 0.1 axis, to do that. 0.1 axis allows you to just take, say, 1 hit on each side of the part as we'd like, and then set those axes as my 0 points. So again, under my cycle page, we'll go ahead and we'll say select points. And in this case, what I'm going to do is I'm going to select on the midpoint here, the midpoint here, and then maybe even the center point based on that as well. Now with that, you're going to see we're going to load up 3 cycles within 1 toolpath. Now what I'm going to do is I'm going to go back to my first one and modify this. Instead of being in a Z negative, I'm actually going to be in a Y negative motion. And you're going to see that's simply going to update to take in a Y negative account. This next one, I want to go down, and that's going to be an X positive, right? And then that way that can go ahead and touch off on that corner. And then of course the third is going to still be my Z negative within that for us. Now by doing that, that's going to combine all 3 of those into 1 toolpath and allow me to then just do the 1 touch, based on those different points. And again, of course, those can be shifted around as needed. No real need for extra geometry to be created. You can simply adjust those X and Y positions accordingly in order to then manipulate the toolpath to where you actually are wanting it. So those are just some different options as far as how we can go ahead and touch off on your workpiece datums. Again, that's just a small portion as far as what the probes can go ahead and offer, on your machines itself and capable of. Again, this is, one portion of it. The other aspect of things is certainly the workpiece inspection as well. So workpiece inspection is going to be where we can actually inspect the part, based on the features and kind of take a look and do some different things, based on that. So jumping back to maybe my original file here, just to show you a couple things, is I'm going in here and I'm going ahead and doing these holes and doing this as a finish. Now I'm not doing the whole entire roughing and this and that of the part, right? You guys kind of already know how to do that. With this though, what I'm going to go ahead and do is then do my contour operations with my wear comp, and then I'm going to go in and I can measure that point itself. Now with that, we are given a couple different options, whether I'm wanting to do that as a 3-point or a 4-point cycle, though it's kind of up to you when programming as far as telling it what do we want to do. And the difference between those is a 3-point is going to go ahead and do that and allow you to select on the different vector angles of the part, where a 4-point is then going to keep that at 0, 90, 180, and 270. Kind of continuing on and jumping into the remachining side of things here, what we can do is some type of in-process inspection. Now this could be obviously, a broad scope of things on what it can mean for different people. But without, trying to treat our machine tool as a CMM, we are able to then utilize that probe in a matter of checking bore sizes and depths and widths and this and that, and also reassign tool paths to that to tell it what, in fact, to go ahead and do. So as I was kind of saying here, with the inspection side of things, we then basically give you the same options as before, and then of course we can go ahead and utilize those as needed. So For instance, as far as one of these circles here, if I wanted to go in and remachine, or check that and possibly remachine, that's where we could go ahead and use like a diameter inside, and we could do the 4-point method or the 3-point method. Now, Renishaw, they consider the 3-point to be a vector cycle, where a 4-point isn't. Again, the 4-point is going to just touch off on the quadrants 0, 90, 180, 270, where then the 3-point gives you that extra little bit of flexibility to clock in those angles as you need them to be. You can see if we go in and backplot this, what that's going to look like. Again, we're just going to drop in there. We're going to touch off on my quadrants. And then based on the toolpath of what we're doing, we're then going to do the different logic that we're telling it. Now, if I go ahead and crack open this operation here, I'll kind of show you what those settings are in the inside. Again, on my tool page, very standard, as things itself. And then, of course, on my cycle page, we're going to give you a couple more options and boxes that we can go ahead and put data into. Now, one of those is going to be a measurement result, and that's going to be an option where we can actually go ahead and output that data somewhere. And that's going to be to put it into a specific variable of my machine. And then it's up to you if you wanted to just leave it there and look at the variable list to see, hey, this is what the value came in as or is set to. You could also do some custom stuff in there to then use those variables of, this variable plus that variable equals this one, or, use some additional options as part of that. Standard stuff you're going to be able to put in there is like your diameters, your X and Y locations, things of that nature, right? And that's all going to be under my variable options. Again, if I wanted to, I could simply click on the tick box, that's going to put it in. And then if I need to, I can also overwrite and say, hey, that needs to go into variable 800, for my code. And then whatever this diameter would be measured to, that would then populate into variable 800 on the control. The other option is then what we call if-then conditions. So we take a little bit different approach on how we treat our remachining operations, and that's going to be where we consider a part to be in one of 3 conditions. It could be in the condition of scrap, it could be needing remachining, or it's within tolerance and we don't need to touch it. Now with that, we're going to have some preset options as far as what do we want to do. Now, instead of having to build out an elaborate tree or this or that, we basically narrow that down to say, hey, if the part is scrap, what do we want to do? Do we want to continue? Probably not. No point in probably putting more machine time into something that we can't salvage. So in that case, we could do like an M0 program stop, or we could even say go to an operation, a group, a program end, something of that nature. Okay. I'm just going to go ahead and elect to say M0. That way we stop as we are. Someone can get, see the alarm, obviously, and then come up to the machine and say, hey, our machine is stopped on this bore. They can check it as needed, things of that nature. If we need to do remachining, okay, what does that look like? So maybe our part is undersized and I need to make an adjustment to the tool and rerun that operation. Well, from here, what I'm going to do is I'm going to say we want to go to an operation, okay, and the operation that I want, we can go ahead and pick out of the list. Now, I strongly do recommend using comments. That way it makes things a little bit easier to see. In this case, this is my front hole 1, right? And then that is the operation that we could go ahead and tell it to use for remachining. And if, again, we're within tolerance, we're just going to continue on the program using the list of operations and not bat an eye at anything, okay? Now, the way that we can tell the probe cycle all the data that we need is certainly we need to tell it the diameter, okay? And that's going to be the nominal diameter that we want that to be as. With that, of course, we have the measuring height, our standard clearance height, things of that nature. And then down below is where we can actually tell it the data as far as when to remachine, when not to remachine, what's acceptable, this or that. So I usually start at the bottom and kind of work my way up, and this is my personal preference on things. But this tool adjustment tolerance zone is going to be when is acceptable, where we're not going to be exactly at 0.657, 143, right? And I'm going to tell it it's acceptable to be within, plus or minus 1.5 thou. So if we are within 1.5 thou of the, 657143 number, we're going to go ahead and ignore it as if we're within tolerance for it. And that way we're not spending cycle time trying to get it dead nuts on the money, because again, we're going to use some of that tolerance. If we're outside of that tolerance, say on the low end and the hole is undersized, well, then we're going to go ahead and do the remachining operation. The tool offset number to be updated, we're going to tell automatic, and then that way it's going to read operation number 7 in order to pull that data. So there's kind of a link between those two. And then of course with that, we can tell the feedback percent. So in this case, I'm going to elect to put it to say 50%. And that way, if it's a 3 thou out, we're going to go half of that. And that way we don't overshoot the hole, especially if a machine has backlash or this or that. And then we're on the opposite side and we just scrapped a part, because maybe I didn't need to take that full percent. Obviously, if we run a cutter on there, a second time is more or less a spring pass, we're still going to grow a little bit, right? So, so that allows us to fine tune, that, and that's a thing that can be adjusted per machine or per part, things of that nature, of course. As far as our dimension tolerance, right? So that's going to be when do we want to actually make an adjustment, to there, and then of course we have our upper tolerance to say when are we actually going to alarm out the machine itself. So if we're over that tolerance, then we're going to go ahead and we're going to alarm out the machine, accordingly. Because again, we're oversized, or maybe we're too undersized too, because maybe a tool broke or this or that, and we're not there. So just some different options on how that can actually be set up, of course. If I go ahead and take those operations and let's say post those out, we can take a look at the output that's coming out of Mastercam here. I'll just take a second. And then we'll see it's actually going to put in all the if then go tos, things of that nature, right? So here's our previous stuff. I'm going to go ahead and say, I don't know, we'll just search a tag. We'll go less than, right? And so what that's going to be doing is here's the start of that cycle. And so it's going to run through that. It's going to go ahead and do my standard, probe cycle at the depth it needs to, and this and that. And then it's going to be doing the logic for us. So that's saying if number 193 is less than or greater than, right, those values. And again, if we pop up here to see a 9814 cycle, right, and 193 is going to be my size error, okay? The size error is going to be where it's putting in not the actual diameter, right? It's not going to put in there 657.1. That's going to be it's going to put in the difference between those two. So say it measured at just 650, right? It's going to put 7 thou and a tenth into 193. And so that way it's going to know what to do, based on that. So we're saying if the error is greater than 1.5 thou, go to here. If it's less than, go to there, sort of thing, okay? And we can go ahead and do the logic, based on that, of course. So that's how the Cimco Probing is going to go ahead and handle that. And then there's different options if you actually dove into this cycle. Obviously we have our diameter, our dimension tolerance value, what tool to update, the feedback percentage, right? So each of those have obviously their purpose within the cycle, that we're telling it, of course. And then of course down here is where we're putting in the rest of the options here as far as, hey, is that scrap? Does it need remachining? Then go to here, or if it's within tolerance, then continue on, accordingly. The other thing that I want to mention here as well is these cycles, we do have the option to go ahead and print data. So you may have seen that option in here. This print data is going to then flip a switch basically in the probe cycle to tell Renishaw, hey, we actually want to output that data somewhere. Now, generally, that's going to be, deprinting. Each machine's a little bit different on how they handle that. Some allow you to deprint to a USB stick. Some are going to be the R232 port that we could use, say like Cimco DNC Max, to collect based on. So that probe data is something that can certainly, be done within there. The other option that we have too, and I'll show you both sides of the posted code, is that with Cimco, we can go ahead and utilize kind of both sides of the token here. For as far as reporting goes, we can utilize information in Mastercam, and we can also utilize information in the probe cycle that we're going to be using. And one of these options here is, say, my custom log. Okay, custom log allows me to go in and set up specifics, measurement routines, and output that in a way that is customized for the machine. In this particular instance, it's going to be if we want to actually go in and like deprint out that information. Okay, and so as far as the reporting goes, that stuff we can do within the cycles. Coming out of Renishaw itself, it's going to look something like this, where it's going to give you a component number and a feature number. That's just standard Renishaw stuff as it is, along with these guys here. The custom log allows me to put in some additional information, such as this line. In the example I had, I just put in what's the Mastercam op number, right? And this isn't of that same program, but again, just an example to say when I outputted it, it was operation in Mastercam number 2. And then of course I want to see, hey, what's the actual probe diameter? And again, we're using these different pieces of information from Mastercam, from the probe cycle, right? And results in the machine in order to go in there and tell it accordingly, based on that. And I do have it down here, I believe down towards the bottom of that cycle, where again, this would be the raw output that would come in there. So on the Haas, for instance, we can do a deprint statement, and then it has to be formatted in a way like such to basically say, we want the Mastercam op number, okay, followed by then the Z position, and that's using this pound 187, putting one number in front of the decimal, 4 behind. Same thing with my Z error as well. Once the machine would read that, it would go ahead and know what to do and then spit that data out accordingly. Same thing for this guy here. So again, it allows us to use different pieces of information, both on the Mastercam and the Renishaw side, to create those cycles and report it out accordingly as needed. So again, that can be done for a number of different ways, whether it's going to be remachining based off of a bore or a boss, a depth. The possibilities are fairly endless. Again, you're going to be, in effect, then just limited to then the cycles as far as what you want to do. So again, if you wanted to remachine or do InProcess inspections based off of width of slots, or rectangles or diameters, corners, points, you name it, obviously those cycles are going to be there for you to go ahead and use, of course. So I think that's all I had, for the time being here. I was just looking through my notes. I guess the one other thing I would mention is looping back quickly to say that variables here. One option that you could do, again, being that we're on a Haas machine, would be set up your control where you can go ahead and read off of a variable. So this is a screenshot I just took off of there, where we could actually label a location and tell a macro number, and then that way on a control like this, it'll go ahead and display that. So that way, if I did a bore cycle and I said, hey, I'll put the actual diameter to variable 800, that result would right away be displayed on my screen for me to see. Just a little helpful piece of information at time. Maybe if an operator just looks up at that and it's measuring this cycle, they know, oh, okay, that needs to be the 651 number, and then they can kind of see where they're at with it, especially if they're not utilizing the full remachining options as far as telling it when to remachine, when not to, things of that nature. So